Welcome to A-Level and AP Physics. In today's lesson, we will discuss an important past paper question on thermal physics from March 2021, paper 4.2. In this question, we will explain why the specific latent heat of vaporization is much greater than the specific latent heat of fusion for the same substance. We will also answer questions based on specific heat capacity. For part A, we need to use simple kinetic model of matter and we need to describe the structure of a solid. So this is kind of very basic question. So we have to write down some points about structure of a solid using simple kinetic model. The first point we can mention about structure of solid is particles in a solid, they are closely packed together. And the second one we can say about the vibrations means the particles in solid, they vibrate about fixed positions. They do not change their position. They do not change their positions. It simply means that the shape of a solid is fixed. We can also mention about intermolecular forces. Intermolecular forces among solid particles are much stronger than intermolecular forces in liquids, and also much stronger than intermolecular forces among gas molecules. So these points, if we write, we will get 2 marks. Now let me show you how you can write down a proper answer. So this is how you can write down your answers. You can see in this answer I have mentioned particles in a solid, they are closely packed in lattice structure. Particles can vibrate about fixed positions, but they do not change their positions relative to each other. And also I have mentioned intermolecular forces among solid particles are much stronger than intermolecular forces among liquid and among gas molecules. For part B, it is given to us the specific latent heat of vaporization is much greater than the specific latent heat of fusion for the same substance. Same substance, let's imagine that we are talking about water. So if you look at specific latent heat of vaporization of water, it is much greater than the specific latent heat of fusion of water. So this is what question is telling us, means for the same substance, any substance you can take. Next thing, question is asking us to explain this in terms of the spacing of molecules. So first of all, let's try to understand what is specific latent heat of fusion. It simply means that when solid change into liquid, if we have 1 kg of solid, it changes into 1 kg of liquid at the same temperature, means temperature does not change in this process. So the amount of heat we supply, that is called specific latent heat of fusion. Now we also need to look at the separation between molecules. Molecules in solid, they are closely packed, almost closely packed, little space among molecules. It means the potential energy of the molecules increases a little, not a lot. We can say little bit. Potential energy of the molecules increases. And to increase the potential energy of the molecules, the amount we supply, amount of heat we supply, that is equal to increase in potential energy of the molecules, because in this case temperature does not change. So it means in this case the Q we need to supply, that has to be small, little. So that's the reason specific latent heat of fusion is very small. Now, if you look at latent heat of vaporization, we can also simply understand in this case when liquid changes into gas. In liquid, the molecules are close together, but when liquid change into gas, molecules are far apart from each other. So it means in this case, temperature does not change, kinetic energy of the molecules does not change, but the potential energy of the molecules increases a lot. So if the potential energy of the molecules increases a lot, it means Q supplied has to be a lot. So that's the reason the specific latent heat of vaporization is much greater than the specific latent heat of fusion. So let me explain to you how you can write down your answer. This is how you can write down your final answer. So you can see during the boiling process, means during vaporization, increase in molecular spacing among molecules is much greater than during the melting process. So that's the reason more work need to be done or more energy need to be supplied when the liquid is changing into gas. So this is how you can answer. If you write down this point, you will get 1 mark, and that is B mark, meaning it has to be in your answer. For part C, the graph between temperature and time is given to us. Now, if you look at this graph, you can see initially from here, you see the temperature is rising with time. But after that, temperature is not changing. So this is simply telling us this is specific latent heat of fusion. It means the melting is taking place here. So we can simply write down here, the substance is melting. So this is melting process. So substance is melting here. So in this time interval, the amount of energy we will supply, that will be equal to specific latent heat of fusion. And then next we can see the temperature is again starts rising. So the temperature is rising. So it means that in this case, the amount of energy we have to supply, that will be equal to specific heat capacity. So this will be equal to specific heat capacity. Simply we can write down specific heat capacity. If we are talking about 1 kg of substance, if the mass of the substance is 1 kg, the amount of energy supplied between this point and this point, or you can say in this time interval, that will be equal to specific heat capacity. Now, if you look at this now, this is again horizontal line. So what is happening here? In this case, the phase is changing now. So here the substance was melting. Here phase is again changing. So in this case, substance is boiling now. So it simply means that the liquid is changing into gas. So simply we can say phase is changing, means the liquid is changing into gas. When the phase is changing, kinetic energy does not change because temperature of substance does not change. So now the phase is changing, simply we will say potential energy of the molecules is increasing and the separation among molecules is increasing because the potential energy of the molecules increases. And this point we have already discussed in the previous part. When something boils, amount of energy supplied is greater than the amount of energy supplied when something is melting, because in this case molecules, the separation among molecules is much greater than the separation among molecules when something changes from solid into liquid. So that's the reason we have mentioned specific latent heat of vaporization is much greater than specific latent heat of fusion. We will need this graph to answer next questions. So let's move on to next one. For part C1, question is simply asking us to determine the temperature at which the substance melts. We have already discussed substance is melting here. The solid is changing into liquid. Now simply we need to write down this temperature, and this is negative 100 degrees Celsius. So simply we have to write down this one. For the second part, power of the heater is given and power is equal to 150 watts. Question is asking us to use data from figure 3.1, and this is figure 3.1. So simply we can write down this is figure 3.1. We need to calculate in kilojoules per kg the specific latent heat of vaporization of the substance, means we have to calculate L. L is the specific latent heat of vaporization. Now, a simple way to start this question is we can simply say Q supplied means the amount of thermal energy supplied. This is equal to latent heat of vaporization plus Q lost, means the heat loss. But in this question, it is given to us our apparatus is perfectly insulated. So it means that there is no heat loss. So simply we can say this is equal to 0. Now Q supplied, how we can calculate? So Q simply we can calculate. Q will be equal to power of the heater times time. And this is equal to M times L. We need to calculate L from here. L is specific latent heat of vaporization. So simply we can write down this is power of the heater times time divided by the mass divided by M. Now power of the heater is given. This is equal to 150 watts. And the time you can read from the x-axis. So you can read time from x-axis. If you read time from x-axis, this is equal to 5.5 minutes. And you have to multiply this one with 60 because you need to convert into SI unit, means into second. And you need to divide by the mass of the substance. This is given in kg. So simply we can divide. So our final answer will be 1.1 times 10 to 6 joules per kg. Question asks us to calculate in kilojoules. So simply we can write down. This will be 1.1 times 10 to 3 kilojoules per kg. So this is our final answer. 1.1 times 10 to 3. So this is final answer. For the last part, question is asking us to suggest what can be deduced from the fact that section Q on the graph is less steep than section P. So first of all, let's try to understand specific heat capacity. So specific heat capacity of the liquid we can calculate in this region, means from here to here, and the specific heat capacity of the gas we can calculate in this region. Now, first of all, let's write down what is specific heat capacity. Specific heat capacity Q is equal to mc delta theta, and this is the change in temperature. But for this question, it is given to us the heater has this power, so we can divide the both sides by time. So now this is the power, and here we also need to divide by time. So we can simplify this one. We can say in this case the P, this is equal to mc delta theta divided by time. Now the P is the same because we are using the same heater to heat liquid in this region and gas in this region. So P is the same, and the mass is the same. Mass of substance is also same. This is greater, it means the C is lower. But for this question is already it is given to us that section Q is less steep. Section Q is less steep. So simply we can write down here now. So this side we will discuss P and this side we will discuss Q. So for section P, delta theta over T, this one is greater because this one is steeper. So it means the C of this section, this will be lower. So you can see from here. But for the Q section, delta theta means the gradient. Actually, we have temperature on y-axis and we have time on x-axis. So that is the gradient. So that is delta theta by T. So for section Q, this is less. So it means the C of section Q is higher. Or simply we can say the specific heat capacity of gas is higher than specific heat capacity of liquid. You can also use numbers, but this is a simple way. Now let me show you how you can write down your answer. So this is how you can write down your answer if you have written this one, or simply you can say specific heat capacity of gas is greater than specific heat capacity of liquid. You will get 1 mark.